The Xenier is not an ordinary diode in the same way as the silicon rectifiers we've been looking at so far. It is a specialized device for one particular purpose, and that purpose is voltage regulation. You might remember that the characteristic of a typical diode looks as shown in the diagram on the screen. When a diode reaches reverse breakdown, it normally fails catastrophically. However, if a diode is specifically designed, the reverse breakdown region can actually be used beneficially. One such diode is a Xenier. To see how this works, note that in this region, no matter what current is drawn, the voltage remains constant. Because of this, the diode can be used as a constant voltage source. We can design a Xenier diode voltage regulator as follows. Firstly, buy a Xenier diode with a breakdown voltage, which is the value of voltage which you wish to produce with your power supply. The diode will have a maximum allowable power associated with it, for example 1 watt. Secondly, calculate the maximum allowable current from this maximum power, because current is equal to power over voltage. So, for example, say we chose a 5 volt 1 watt diode. I equals P over V is equal to 1 divided by 5 is equal to 0.2 amps or 200 milliamps. Thirdly, choose a value of resistor to limit the current to this value. The maximum current runs through the diode when no load is present and there's nowhere else for the current to go except through the diode itself. The value of resistor would therefore be R is equal to V in minus V out divided by I max. So, say the input voltage is 12 volts. Then in the power supply described above, R is equal to 7 divided by 0.2 is equal to 35 ohms. We can add this circuit to our linear power supply which we discussed in the previous video. The Xenier regulator produces very good results, but we can make an even better regulator using transistors, and so we'll return to this topic later in the course.